In this video, we're going to look at the Lotka-Volterra predator-prey equations. Suppose we are looking at a closed environment, a single lake, for example, that houses two species, one of which preys on the other. When the model was developed, it was to study sharks and food fish in the Adriatic seas. Call the predator population Y and the prey population X. We'll make the following assumptions. First, we'll assume that there is no shortage of resources for the prey population. If the predators weren't around, its population would grow exponentially. However, there are predators, and obviously the more predators there are, the more likely it is that prey animals get eaten. More precisely, since there are X prey animals and Y predators, there are X, Y ways that a prey animal and a predator could interact. Call P1 the probability that a randomly selected prey animal interacts with a randomly selected predator on a small time interval. So this is the number of interactions on that time interval. Call P2 the probability that an interaction ends with the prey animal being eaten. Then over this time interval, this is the number of deaths due to predation. We let the time interval we're looking at go to 0 to get to the first equation in the Lotka-Volterra model. We're subtracting acting because this predation term is driving down the number of prey animals. This is classically written with this common x pulled out. What about the predator species? Well, if there were no prey animals, they would all starve. The more predators there are, the more predators there are to starve. So the deaths are proportional to the current population. They are saved from this fate by the presence of prey animals. Just like we have a negative pxy term here representing predation, we have a positive qxy term here representing the same thing. Predation is bad for the prey and good for predators, which is why this is positive and this is negative. The P and the Q are different because there's not a one-to-one correlation between how many prey animals die versus how many predators are fed. For example, an entire pack of wolves might subsist on a single elk. And here we have the classic predator-prey model. In this video, we have introduced the Lotka-Volterra predator-prey model. Later, we will investigate this model using the Jacobian.